So let's talk about finding that second triangle. Um, the picture I drew freehand wasn't really very accurate, and the reason why is because the angle that I had was for B was super skinny, and the picture I drew was meant for a fatter angle, and that was just because I didn't know what the angle was. Now that I've solved it, I can kind of draw the triangle that I had. Um, 30 degrees is still pretty skinny for A, so I should draw a ray going through about 30 degrees. That's 29.7. I should go ahead and plot my vertex for my angle B. And I guess I'll click on this one. The vertex for angle B, I'll just plot it over here. This is what B looks like. And I get to realize is that since B is less than 15 degrees, less than half of this angle wedge over here, it should go back in this sort of angle that looks like this. If and I'm going to go ahead and plot a just my C prime. So the C that I get, the triangle that I solved in the previous video would look more like this. And if I look very closely, I could start to see that maybe, I'm going to draw a little horizontal line here for my height. Maybe there is another ray going through that vertex B right over here that shoots off and gives me exactly the same length of little a over here. So sort of a mirror image, so to speak, of that vertex. So I'll do my best to just sort of estimate what that mirror image looks like. I can, you can see there are lots of different options. That doesn't look like a mirror image. Keep going, keep going, keep going as best I can. That looks like a mirror image based on this perpendicular relative to the bottom right blue line that represents my height. And so I would say that probably I have a side opposite A. This will be the other side opposite A. These two A's have the same length. The point is that A is large enough that it can intersect this ray and give me two different vertices that are going to solve a triangle. And so now I'm going to call this C prime, and just to make things work out, I'm going to call this A prime. That vertex stays the same, however, the angle is going to be different. And I will show you how to find that angle. And the trick is that you take the B you already have, I'm going to call this now B prime. And to find out what B prime is, first just take 180 degrees because it's kind of a reflection, and minus out your actual B that you had, and you calculate it to be, I guess in this case, it's going to be approximately equal to this 165.9 degrees. Okay, so I think this is not an angle that the example has two solutions, and we'll find out why. So I drew a picture suggesting that maybe there's another solution if I draw things out, but we'll see why there shouldn't be in a second. So if there's another solution, it really should be the negative of the above angle. So it really should be um, the other angle should really be 180 degrees minus the angle that I found, which gives me 165.9 degrees. If I continue with this problem, I'm going to go ahead and say that in order to find out what that C prime is, I have that same old trick, 180 degrees minus, this time I'm going to say my A, which was always there, minus my new B prime. But if I do all of that, I end up getting 180 degrees minus um, this 29 point, I guess, 7 degrees minus this 165.9 degrees and blah blah blah. This whole thing gives me a negative number. That is, I've these two pieces are larger than 180. And since I'm talking about the interior angles of a triangle, they have to add up to being 180 degrees, which means I need a number. So I can't get a negative number from this equation. So I'm going to go in and say there does not exist such a C, does not exist. And this is actually an example where there's only one solution, although